Welcome to Advanced Java Programming at Portland State University. In this screencast, we continue our discussion of Google Web Toolkit, starting with a discussion of how it localizes strings. Okay, localization. Remember we talked about date formatting and text formatting, and we talked about localization, the fact that applications should be able to format their dates, their times, and maybe even their strings, the text that they display in the user's preferred locale. Well, this is especially important for web applications, right? Because your customers might be from all over the world, and you want to provide an experience that is familiar to them. So you want to format, numbers, dates, currencies, text, string, everything like in the language that in the formats that they expect. GWT has really good support for this with the date time format class and then the number format class. It also takes an interesting approach to localizing strings with classes called constants and messages. A common mistake that a lot of people would make is that they would write all of their application in and have all of the strings and text displayed in one language, English usually. And then the requirement would come down and say, oh yes, now we want to enter into the Chinese market, so now we need it all translatable into Chinese. Or hey, wow, we've got this German customer that will make us a lot of money, and so then okay, let's have it all in German. And the developers say, well, that's going to be like a 6-month project because all of our strings are hard-coded into our source code, and we have to go extract them out and replace them with some way of localizing it. Well, GWT encourages you to localize your applications from the beginning using the method I'll talk about right now. So basically what you do is you define a special interface whose methods return the string. So it's an interface that has a bunch of methods that return string values. Then what you can do is you can specify maybe the default value for a particular string constant, and you can also define constants that are other types like numeric constants, or maybe array of strings, which is some constant is translatable, stuff like that. And so you have this interface that has examples of here are these methods that I call to get my strings that might be localizable. And the way you get an instance of this interface is you use that magical gwt.create method again. And by calling create, the compiler will then generate very efficient JavaScript code for getting those constants. And maybe it doesn't even get them. It might even inline it. I'm not too sure what it does. I don't really care because I know that it works, and this is the pattern that I should follow. So here's an example of this. Here's an example of doing a date localization, and it has two constants. One is called select string, which the default value. So if you're not running in any other locale or in an explicitly called out locale, you say input your date of birth, and then there's another string, which is default days message, which is how many days have you been alive, and this is what it computes. Is how old you are. If you go and look at the source code, the most relevant stuff is actually getting these strings to display. So we use GWT create, and you give it a reference to the class for that interface, and that will create a magical instance of it. And now when I call default days message and default and select string to populate these labels, the magical object that GWT create created will return the appropriately localized string. Now strings those were constant values, meaning that the entire string is just right there. But you might also have what are called messages, meaning that you've got some text with some value embedded in it. So for instance, an error message saying that okay, yep, you provide me bad data. You want to then have the error message include here was the data that you entered. And so to do this, you use an interface that extends the messages interface, and methods on the messages interface take parameters. So for instance, this is like how many days that you've been alive. That will take a number of days and return a string. Here again, the default message is this guy right here saying, hey, listen, argument 0, which is this long days, should be formatted as a number. Should be formatted as a number in the locale that you're running. The nice thing about this is that this is all type safe, in that when the GWT compiler goes to compile it, if I have a Boolean here and I'm telling it to format a Boolean as a number, it'll blow up at compile time. So you don't need to worry about things blowing up at runtime, or at least that particular failure at runtime. So we've seen how that annotation can be used to specify the default value of messages and constants. But if you want to localize a message or a constant, you can do so by the following: by putting a properties file that resides in the same package as the interfaces. Something like, okay, if I want to provide the Spanish localization of my strings defined in the date localization messages interface, I would have a file called date localization messages _ es for Spanish, dot properties. And I have these key value pairs in there. So I'd say day message is usted ha estado vivo durante, you'd have your number there, días. Notice here that I've encoded the I with the accent over it using this notation \U00ED, and that is the Unicode encoding of that particular character. Similarly, for the constants, the date localization strings, I have select string as ingreso su fecha de nacimiento, and default days messages as cuántos días has vivido. Here again, this is like the upside down question mark and stuff like that. And I think the thing that's important to note here is that the key in the properties file must match the name of the interface method. So it's not like a get convention, it's the same. So select string here is the same as select string there. And I guess also GWT can handle properties files that are UTF-8 encoded, but I prefer to have everything in ASCII, even if you do have these crazy escape characters. Editors can sometimes mess up UTF-8 encoding and stuff, and so it's just easier to escape everything. So GWT does some interesting stuff when it comes to localization. First of all, you need to tell GWT, the GWT compiler, which locales are supported. And so you do that in the GWT module file, the gwt.xml file. So here, in addition to my entry point, I also use this extend property tag. Name is locale, and the values are, well, I only have one value. It's es for Spanish. And what the GWT compiler does the following. So when it compiles your code, it makes essentially multiple passes over that code for each locale. And so then what basically GWT does is compiles a separate version of some of your classes for each locale. And so this way the code is optimized for that particular locale, and so things run very quickly. So when your page is rendered and your JavaScript is running, it doesn't look up the value of the translated constant or the translated message every time. Instead, it's hard coded in to the into the JavaScript, and I think this is a reasonable trade-off. Basically, what they're saying is that, listen, we're going to do more work at compile time, more time at build, and more work at build time. So then at runtime, so when your customer is using your application, it is as fast as it can be, as opposed to saying, well, we're going to make the build go faster, and the cost is that at runtime we're going to be looking up these strings all the time. And so then this minimizes the number of calls to get the localized strings, lets things be inlined, just makes it all around better. Now, when you're actually running in locale, GWT will figure out the locale in a couple of ways. First of all, you can set it explicitly via a URL parameter, say locale equals es, the URL. You can also have the HTML that is the host page specify the a meta tag GWT property and then content locale equals es in there. And that's like maybe if you were generating the host page dynamically with a JSP or something like that. You can then set that property via the accept language header from the HTTP request. That's the browser say, oh yeah, here is the language, here's the locale that I care about, and then set the meta tag dynamically with a JSP. Okay, let's take a look at this. Let's go then to localization. Here it is in the default locale. Input your date of birth. So okay, yeah, there it is. Oh yeah, use little calendar widget. July 19th, 1984, sure. And tells me that I've been alive for 10,593 days. Okay, that's kind of neat. But then let's put another URL parameter on here. Let's say locale equals es. It reloads the entire application, which here again is a little slow because there's a lot of JavaScript there, and we're running in development mode. And now all of the strings in this example are translated into Spanish. And note here how the date is formatted, and even the calendar is translated is localized rather is localized for Spanish. This is how many days I've been alive, and notice that the 10,000 is formatted using a decimal point instead of a comma, just like you'd expect for the Spanish language. Browser history. So remember how I was saying these rich internet applications tend to be just a single web page, right? You download the HTML once, you download a whole bunch of JavaScript to handle all of the logic, and you stay there, right? When you click buttons, when you interact with it, you don't reload the entire page. Instead, you're making these AJAX calls using the XHR object to get content. So then, what happens when they press the back button? Well, you go back to the last page, which is like, who knows what, eBay or Gmail or whatever you were using. And this probably isn't the behavior that you want, right? People have gotten used to using the back button to mean, oh, we sort of go back to the last thing that I was doing. And probably what happens is they press the back button, they see eBay, they're like, oh, oops, that's not what I wanted. And then they hit forward again, and then your entire web app reloads. You've probably lost a lot of your UI state, and it's just not the behavior that you want. So GWT has as a nice facility for basically maintaining application state so that you can use back and forward and still have it be meaningful. The state is kept in the URL fragment. That's the anchor there in the URL. And and one of the reasons that it does this is by navigating to an anchor. So if you just go to a URL that has an anchor, or the only thing different about the URL is the anchor, the browser does not reload the page, right? This comes back from old HTML where the anchor was used just for positions within the a big long document. And it also lets the application have URLs that can be bookmarked, because all of a sudden you've got a URL, whatever there in your anchor is is a description of what is supposed to be displayed, or sort of the place in your application. So how does this work? Well, there is this class called history, which is used to maintain the browser history. And the way it works under the covers is pretty cool. There is an invisible iframe that you add to the HTML file, that you add to the host page, that basically handles the previous and next behavior. It's the thing that keeps track of the URL history. Basically, what happens is when a page is loaded that has the anchor has that place, it pushes it pushes that a token, a history token, on this history stack with history.new item. And so, hey, I've done something in my application. I have navigated to a place within my application. I'm looking at a particular piece of data. You can push that place on the history stack. Then, when a place, a URL is loaded. Oh, I guess here's an example of this. And so, actually, let me show you. And maybe you've noticed this already. Look at the anchor in this URL. It's here at localization. And when I click to client server, it changes to client server. And when I click to events, it changed to panels. And now when I use the back arrow, I go back to those same places. So these examples here actually use the history functionality to keep track of where you're at in the examples. Basically, which tab of this outer tab panel has been clicked. And the way that code looks is the following. So I added a selection handler to my tab panel. And selection handler is a selection event is fired every time the tab is clicked. And it does the following. It says, okay, depending on, well, it'll then say, okay, when this guy is clicked, get me the selected item. Selected item, I believe, is an integer. Get me the widget at that index in the tab panel. That's going to be an example panel. And then I'm going to pop onto history, panel.getTitles. That's the title of the panel, which is something like, events. So that goes in the history, that updates the URL. And I say false here because I don't want to then fire a change event based on that, because then it'll just get reloaded and stuff like that. It's nasty. When you want to then handle a page being loaded or the back arrow, you basically need to register a value change handler on this history object. Say add value change handler, and this gets invoked, well, whenever the token changes. The token is what's there in the event. So basically, you get the token, and then you put your application in whatever state it needs to be in. So for instance, what I do then is I set the tab that's currently displayed to the value of the token. So when your entire web page is loaded, like the first time you visit it, or if you hit reload in the browser, if you have a call to fire current history state in your module on load, then it will fire the appropriate value change listener based on the URL that was loaded. It looks at the anchor, and then we'll send that off to the value change listener, and that'll sort of get your application in the initial state. Okay, one more topic. How do you test GWT code, right? I mean, you're a Java developer. You want to write tests for your code. You might be thinking, wow, this stuff is really complex. I really want to be able to verify all this logic using test-driven development so I know I'm doing the right thing. Is that possible? And the answer is yes. Now, your code for the server side, your all the business logic and stuff, that's just plain old Java code. So that can be tested using, however you're doing it now, JUnit, Mockito, which we'll learn about later, etc. Client-side GWT code, though, isn't regular Java code in that you've got code that represent the code that gets compiled into JavaScript. You need to you have things like buttons and list boxes and browser history, and all this stuff doesn't really exist in the Java world, or rather, you need to go to extra lengths to make it exist in the Java world. So if you have just regular, client-side business logic, you can test that with JUnit. But with widget code, you need to have all this stuff that provides the stuff that you have in JavaScript. So like access to DOM, calls to GWT services. Well, JRE I suppose is going to be there. And it's, the GWT class, right, which does all this magical stuff in the browser. Well, there is a class called GWT test case that provides the framework for writing JUnit tests that are executed in development mode. Basically, these are unit tests that can be run that are run in GWT development mode, hosted mode, and then provide all the environment that you need. It leverages a library called HTMLUnit that simulates the browser environment. So you can have access to. So it's like you're running inside a browser, but it's really all just Java code. When you create your GWT test case, you need to override the get module name to tell the GWT framework, the test case framework, what module you're running, and so then it'll go off and find the module XML and everything like that. But the nice thing about this is that this is a JUnit test case, and so you can run it with the JUnit test runner, and so it fits in very nicely if you're using JUnit. So you can get all the same reporting, etc., etc. An interesting detail here is that when you're testing GWT client code, you have these asynchronous method calls off to the GWT RPC services. So usually what your test has to do is wait for something to happen asynchronously before verifying the test state. But you can't really be spawning off threads and things like that because that's not supported in JRE emulation mode. So the way it does this is that the GWT test case provides a method called finish test, which basically tells the framework, oh, yep, listen, we have validated all the state. So once you say finish test, then the test is really finished. You can call delay test finish, which will say, hey, wait for some number of milliseconds for finish test to be called. And so what this does is it puts the test into asynchronous mode. It'll basically wait for the finish test method to be invoked. If you want to wait a little bit before calling delay finish test, you can use the timer class if you want to give it a little bit of extra time. So I call these GWT test cases unit tests, and they are implemented with JUnit, but really they're more like integration tests than they are unit tests, meaning that, well, they're heavier weight because they depend on development mode and a GWT server to be running because it's actually making remote method calls and stuff like that. There is a goodly amount of harness to just start up, and also because they're unit tests Well, it's actually a good idea to define a GWT module just for those tests. So basically, instead of having like your entire program just have a module for those tests. And so then I have a module defined something like this. And as a matter of fact, there are examples of these unit tests in the archetype for your GWT project. So you define the servlet there, which is just the way GWT test case works. You can go up and read on this. There's really good documentation about it on the Google Web Toolkit website. Okay, this is what a GWT test case looks like. So here I have a simple test for my division service. What I'm going to do is the following. Okay, first I need to tell it which module it's using, and so there's the module right here. And the test does the following. It creates an instance of the UI class, our division service example. And then what it's going to do is it's going to get at the text field objects for the dividend and the divisor, and then it's going to click on the equals button, and then it's going to verify that the expected value came back. How does it do all that? Well, okay, so first it creates an instance of division service example. And by the way, that's going to create all of its text fields and things like that, so it's going to use the framework provided by the GWT test case to create an emulation, a simulation of a browser environment where it's actually got real things where it can handle mouse events and things like, where it can generate mouse events, things like that. In order to allow this code to be tested, I made the dividend and divisor fields package private. So because this class, the test class, is in the same package as that, it has access to those fields. So it'll set the text to the expected value of the dividend and divisor, and then it's going to click the equals button. I think I had to play around to get the click working exactly, and so there's some detail to this click method here. Here's a little bit of detail of how I actually click that button. I had to create a native click event in order to do it. Maybe it doesn't work this way anymore. Maybe there's a better way to do it now. I thought it was a little lame. When we click the equals button, what that does is it fires the event off. The event then in turn is handled, and as you'll recall, it invokes the remote method. It invokes the divide method, and because it's the client code, it has an asynchronous callback. And so then we need to wait until that asynchronous callback returns before we then go and verify that yes, the quotient was set appropriately. So what I did there is I used the GWT timer object, and I basically say, hey, I'm going to create a timer that when it gets fired, when it does its thing, I'm going to assert that the value of the quotient text field is what I expect, is the quotient from my unit test back here, which is going to be 2. And then I'm going to finish my test. What do? I'm going to say, hey, I'm going to wait 500 milliseconds for the RPC call to return. So I'm going to say verify.schedule. Timer has the schedule method that says, hey, wait for 500 seconds. And then I'm going to say, hey, wait 1 second, 1,000 milliseconds for the test to finish. So think about it. This is like asynchronous code. This is synchronous code. So let's go back here. So to my test division UI, I go and I create my example. I go and I set up the test condition. I click the button, and then I'll fire off a timer that says, hey, wait up to, I'll fire off a timer that says, wait 500 milliseconds, and then run this method, do the assert equals, and call finish test. If finish test is not invoked after 500 milliseconds, or the assert fails or whatever, back here. So I call this guy, and then I say, this goes off and waits 500 milliseconds asynchronously. Then I'm going to say, hey, listen, this thread should wait up to 1 second for finish test to be called. It's concurrent programming. There's multiple things going on at the same time. I don't know how well I'm doing explaining it, but I think once you start working with this code yourself, you'll see how it works. Like I was saying, these GWT unit tests, they have a lot of overhead, right? You've got launch development mode, you've got to compile some Java into JavaScript. There's a good amount of stuff going on there. If you want to be able to run a bunch of test cases all at once with only one set of setup, you can define a suite of tests using this GWT test suite. And if you have a static suite method, this is like old style JUnit. You can create one of these guys in a GWT test suite, add a bunch of test classes, and then do it that way. So Google Web Toolkit, GWT, allows rich internet applications to be developed using almost exclusively just the Java programming language. This is good for Java developers who are familiar with a set of tools, a set of programming practices, a set of APIs. It allows them to stay in that environment, and so they don't have to learn as much about JavaScript or JavaScript libraries, things like that. The way GWT works is it has a special compiler that will compile Java source code into JavaScript, which is ultimately run in the web browser. Working with the GWT API is a lot like building desktop applications, especially desktop applications that are written in Java. So they have classes that represent user interface widgets, containers that are responsible for laying out widgets, and listeners that handle user events. GWT's runtime environment is a little interesting. They have a hosted mode that's used during development that allows for easy debugging and a quick turnaround of changes. And then when you want to deploy for real, you run in web mode. That's when all the JavaScript compilation happens, and GWT applications just get deployed inside a standard Java web archival WAR file, just like any other Java web application. It also has good support for localizing strings and messages, so that you can not only provide a user interface that is familiar to your user, that's in their local language, but it also provides type safety, so that you can be sure that things will. So you find out at compile time if you've made a mistake in terms of trying to format something that's not formatable. Now, web applications are distributed applications. It's distributed software. It's multi-process. So you've got stuff running on the browser, stuff running on the server, and they need to talk to each other. GWT provides a really nice abstraction layer over that communication called Remote Procedure Call, RPC. Because it's Java, GWT code can be tested just like any other Java code. If you want to be testing that client-side code with all of the browser stuff there, with the widgets, with the RPC, you've got to use a GWT test case. That invokes some overhead, but it can be done. And it's a heck of a lot better than not testing your code at all. Okay, and that's it for Google Web Toolkit for now. In a future screencast, we'll be diving into more detail about some of the more advanced things that you can do with GWT. And we'll also look at better programming patterns that will then help you test more efficiently. So that's all for now. So thanks for listening to the screencast for Advanced Java Programming at Portland State University.